See the unseen, change the unchanged.
We have some questions for you, and my first question is about why is Harbin School such an important discovery? Give some details to explain it.
From my point of view, yes. I mean, first of all, the cranium is so complete, so it has so much information. We have a date for it of at least 146,000 years, and I think that it helps us interpret some, let's say, less complete or less well understood fossils from China that already existed. So some of those are not so well preserved, or they've been reconstructed, and they've been interpreted in many different ways. I think Harbin helps us clarify the story of human evolution in Asia as a whole.
Okay, the second question is about what's the unique feature for Harbin School? Unique feature.
Well, I think it's, in terms of a single unique feature, for me, there isn't a single unique feature. It's a combination of features that is so interesting. The fact that we have, in some respects, a primitive morphology with a big brow ridge, a long, low skull, very large size. That is maybe the single most distinctive thing, is the huge size of the cranium. But when we look at the face, we can see that the details of the face are very like what we find in Homo sapiens, and the face is tucked under the brain case in a way we find with Homo sapiens. So that combination is very unusual, and I think is unique to this group of fossils from China.
Create a new name, long guy. How do you think about it?
Yes, so I think that this group of fossils certainly is distinctive enough to warrant a new species name. So if the Neanderthals are regarded as a distinct species, then this group is equally distinct, both from Neanderthals and from Homo sapiens. So I think it deserves a new species name. Homo longi is a great name, Dragon Man. I like the name very much. But personally, I think the similarity with the Dali skull is important. And for me, I would suggest that the name Homo daliensis is equally appropriate for this fossil and for this group.
Do you think what they look like when they live, when they still live?
So what do I think he looked like when he was alive? Yes.
Yeah, you got me.
Yes. So I think that obviously the head is very large. We know that. We can't be sure about the rest of the body, but I think a very large body. And in terms of the face, yes, a very broad face, a rather flat and bulbous nose, obviously a big jaw, big orbits, so big eyes, a strong brow ridge, of course, over the eyes, but the cheekbones with a rather modern shape. So I think the color suggestion is a very good one.
Oh yes, just now you mentioned the genetic code. Do you think it is possible to get the genetic code in the coming future? Get the genetic information?
Well, I think it will be important to try and get some genetic material from the fossil, but of course this is destructive. It means removing some material.
Yes, it's an old time, and would you like to give us some imagination how long guy lives in ancient time? How they live?
Yes, so of course we don't have archaeological material. This would be a population living off the land, hunter-gatherers and foragers, eating plant and animal material. They would have had stone tool technology, probably wood technology. We don't know how complex, of course, the behavior. We don't know how complex the social system. Hopefully we will get more information.
Because the Harbin School is so cherished, do you think it is possible to get more Harbin School in the same area? Is it possible?
Yes. I mean, I think that there must be other fossils in this region. It's unfortunate we can't tell exactly.
How old was Dragon Man?
So you said it's middle age, and so we guess it's around 50, and better maybe younger, right?
Yeah.
At least 146,000 years from the uranium series determination. It might be possible to, in the future, to get a more exact age, but it's a very interesting age, an important time in human evolution.
So what does its placement in time tell us about Homo evolution?
Yes, so what our analyses suggest is, first of all, we have a distinct lineage of humans in Asia. So this is something that's been argued about. Some people place these fossils like Harbin and Dali as intermediate between Homo erectus and Homo sapiens, suggesting there was a local evolution.
Why did you join this collaboration for this discovery? Why did you?
It was a great opportunity. I was really honored and privileged to be invited to join this collaboration because I've worked on fossils of this kind for most of my career, my research career. To have such a complete fossil, it's one of the most important finds, certainly of the last 50 years, maybe one of the most important ever in China for human evolution.
By your idea, and you are famous because for the theory after for Africa, and you are a strong supporter of that theory, and also you use a lot of method and in your previous researches. But here, and when we started to do this joint collaboration, joint work, and we explore a lot of new methods, and I really proud of it, and so we can bring these new ideas together, and I'm really happy that you're so supportive and you're open-minded with so many new things for paleoanthropology. So you know the process during the review process, and it's not so easy to convince the reviewers to use new technology to study all the things. So, but I think it's very important for us to use this new technology and give us new ideas. And actually, the third lineage, this theory is consistent with your previous theory. And a long time ago, you brought it up. Maybe there is a third lineage somewhere in the world, not only the Neanderthal and the Sapiens. Now, actually, under our study and the review, there is indeed a third lineage. So this is very impressive. So I want to thank you. How do you think the community, our community, the anthropology community, will think about this? So yes, I think there will be a lot of disagreement and agreement. Some people will like it, but what's your idea? Yeah. So what's your idea?
Yes. So yeah, I think the ideas we're putting forward, the basic description of the fossils the fossils should not be controversial, but the way it's analysed, of course, this is not a typical method to use for paleoanthropologists. So some people will disagree with the methods we've used. Some people will disagree with the conclusions. But I think this advances the science. I think the establishment of this third lineage of humans is pretty clear. People will disagree about how we fit this into the big picture. Of course, we found that this new lineage is more closely related to Homo sapiens than to the Neanderthals. So that surprised me, but we've laid out the methods we've used and we've put a lot of data to that question. So I think in the long term, yes, we must look to establish the relationship of this lineage with more data and test it again. And of course, with any study, this is just the first stage of this study, of this important fossil. So I think we have a lot more work to do. And if we can get some genetic information, of course, that will add to the picture and will give us a further test of the relationship of this Harbin group to these other fossils. But yes, it will be controversial. I'm sure some people will object. For example, there's the question of whether, there should be all these different species. That's the first question. Some people don't agree with that. Too many human species. That will be one question. Other people will say, what about hybridization and gene flow? And we know it happens in human evolution. So doesn't that interfere with the patterns that we create? And I think that is something we need to look at. Of course, gene flow is part of the story, but what we also see is that even in the case of Neanderthals and Homo sapiens, there has been gene flow, but the lineages still remain distinct through time. So our analyses are looking at branching patterns. In the long run, of course, there could be some gene flow involved, but our patterns we think are quite clear. I don't think gene flow is interfering with the main findings that we have of a separate lineage in Asia of human evolution.
Do you have any suggestion, some take-home message to our audience, the public? Take-home message for the public.
Yeah. Okay, well, I think the exciting thing is that, Dragon Man, and it's a great name, Dragon Man. I think Dragon Man is one of the most important finds in human evolution in the last 50 years. And I think it will continue to be important in the future. It tells us that Asia has an important story to tell in human evolution. Chinese scientists have known this, of course, for a very long time. But I think in the past, China and Asia in general has not always got the attention. Dragon Man reminds us that this region is very important in human evolution. And to build a picture of human evolution for the whole world, we need to have the material from Asia, and Harbin is part of building that story in Asia that will help us understand the whole picture of recent human evolution.
He's famous as a dinosaur hunter or dragon hunter, but this time the dragon hunter found the dragon man. So it's a pretty interesting point. Yeah.
Okay.
So right, and Chris, you are right, and the genetic information is really critical for our future research. So that rely on our collaboration with the Hebei Geo University, and we need to get through and manage to get more material and for genetic analysis. But you're absolutely right. We have to be very careful, and because this skull is quite old. And for paleoprotein, and could be, it's possible, but for Asian DNA, we must be very careful about that. But we should do that.
There actually was a three-way split of human lineages: one in East Asia, the Harbin group, one in Western Eurasia, the Neanderthals, and one in Africa, Homo sapiens. Maybe it was a three-way split, and our analyses are picking up these different interpretations of how they relate to each other.
It's rely on in the future, our future research, how to analyze the data, and maybe have to bring more models, mathematical models, and to bring more data, and even combine genetic data and morphological data together. So a lot of things to do.